This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Hello, this is Josh Long for Software Engineering Radio. Today I have with me Cédric Champeau. Cédric is a committer of the open source Groovy language, and he's currently working for Gradle, an innovative scalable build system that internally uses Groovy. He wrote a number of the recent improvements of the language, including static compilation, a templating engine, and more recently, he introduced Android support. He's an open source advocate and a member of the Apache Software Foundation. Hi, Cédric. Welcome to Software Engineering Radio. Do you have anything you want to add to that bio?
Hi. So, no, I think it's pretty complete. No, thanks.
Well, thanks for joining us. Welcome to Software Engineering Radio. We on the Software Engineering Radio podcast like to explore old languages and new ones alike. And Groovy, of course, has been around for a long time. Can you tell us about how and when Groovy was created?
Yeah, sure. So Groovy was created more than 10 years ago, actually. So in 2003 by James Strachan. So at that time, it was a language, one of the first language on the JVM apart from Java, basically. So he wanted to create a dynamic language for the JVM inspired by languages like Ruby, but something that would be closer to Java, to what the Java developers had in mind. And it was a pretty innovative idea at that time, because not many things were done on the JVM apart from Java. And having the idea of creating something dynamic for the JVM was at that time very innovative and probably a crazy idea. And I think today it's more than 10 years that the language has been created. It's used really in a lot of different contexts. And very recently, so just at the beginning of this year, the language just joined the Apache Software Foundation. So it's now really a language which is backed by very well-known open source foundations, so something that is really leaning towards the future.
Did the language live at a sort of foundation before?
So before, it was really a language created by, I would say, geeks, basically. So it was a language developed during the weekends, but it was so impressive what it could do that it really became evident that you could have support, professional support for it. So I think it was in 2008 that a company was created, which was called G21 at that time, by Guillaume Laforge, Graham Rocher, and Alex Stackman at that time. And those guys were really wanted to create something to support the development of the language. So before 2008, the language was created and developed in a totally open source fashion. And starting from 2008, it was company backed. And G21 later was acquired by SpringSource, then VMware, eventually Pivotal. And it's really recently, so at the beginning of the year, that Pivotal ended sponsorships for that language, and that we moved to a foundation. But technically, the language existed before funding of companies. So it was an open source project from the beginning, and it's still an open source project, developed now part of the Apache Software Foundation.
And has the move to the foundation increased or diminished interest and activity around the language and ecosystem?
So I would say it really interested more people, actually, because before that, some people were not really wanted to use Groovy just because it was company backed. So they were thinking that if the company removed money and removed the funding, the language could disappear. And it's true that we have seen some recent project disappearing just because the company stopped funding the project. So because we moved to the Apache Software Foundation, now we see more people on the mailing list asking to help developing the language. So we still don't have released anything yet under the foundation because we have some technical process to follow. We're in something which is called the incubator, and we have to make sure that we follow the release process, etc. Basically, I think that now that we are in the foundation, more companies will be interested in investing into the language, and it will not be seen anymore as the product of Pivotal or before VMware, etc. So a lot of interest, actually. Yeah.
Very good. The original language was, is it fair to say that it was designed to look or feel sort of like Java at the time?
Totally, yeah. And I think it's still true, actually. So the language borrows the syntax of Java. So it makes different semantics on top of that. But basically, if you know Java, if you know the language Java, you know how to program in Groovy. So you can almost copy and paste Java code and it will compile as Groovy code. So there are some subtle differences in the syntax, but in the beginning, the language was really made to work with the Java grammar. So one question, of course, would be, if it is the same syntax, why is it a different language? And it is a different language because it adds a lot on top of Java. So it adds a lot, but I would say it also removes a lot. It removes a lot of boilerplate, actually. So in the very beginning, for example, for those of you who are aware of what a closure is, Groovy added closures since day one. So we had some functional programming features in the Groovy language in the right beginning of the creation of the language, really much before Java, actually. They did the same in Java 8, basically, but Groovy had that since day one.
I understood that up to a point you could take Java 7 code and paste it into a Groovy file and then run that. Is that still true with lambdas, or is there interchangeability there?
No. So because of that closure syntax and the lambda syntax, so in Java 8, we have the lambda syntax, which is for those functional interfaces. And the syntax is very close to what Groovy has. It's not the same, but it also has some very different semantics from the closures. So today, you cannot copy Java 8 code in Groovy just because we don't support the lambda syntax. And we don't support it yet because we want to make sure we made the right decision regarding the semantics of lambdas in Groovy. So it's not that we will not support it, it's really that we want to make sure we make the right decision regarding support for that.
And at any rate, as you say, the languages, the two of them, when compared to each other, it's pretty easy to translate.
Yes. Yeah, I love to say that basically if you take some Java classes, you remove a lot of the boilerplate code and you have Groovy. So it's really, you remove most of the verbosity of the language. So for example, we know that it's really simple examples, but in Java, 99% of classes or methods are public, and in Groovy, by default, it will be public, so you can remove the keyword. That's an example. You can remove all the semicolons, for example. Also, so it's really something that you don't need. Or if you have, something that we also see very often in Java code. It's something like if X instance of something, then you have to cast inside the if just to be able to call the methods. In Groovy, you don't have to do that, etc., etc. So it's really removing all the code which is not necessary. And we have some wonderful metaprogramming capabilities to help doing that.
You just mentioned that you don't have to cast. Does that mean that Groovy is loosely typed, or what does that mean?
So it's a dynamic language at the beginning. What I had done in the last few years is a static version of the language. So you have the two options actually. So you have strong typing. So Groovy is a strongly typed language, but it's also dynamic. So when you don't have to cast, it's actually because you fall back on the dynamic runtime. So when a method is invoked, it is invoked based on the runtime types. So say you want to call the method foo on an object, then it's very different from the Java way of invoking methods, because you will take the object and check at runtime if it has a foo method. So for those of you who are familiar with languages like Smalltalk, it's really similar, because you have a method protocol defining how a method should be invoked. And this is runtime metaprogramming. So Groovy fully supports that, so you can totally override the behavior of invoking methods at runtime. And really, it doesn't mean that it's not typed. It is strongly typed, and it is really because we have strong types that we're capable of handling that. So it was one of the, maybe I would say, problems that some Java developers had with Groovy, because they were familiar with compile time errors. For example, if you try to invoke a method which doesn't exist on an object statically, they didn't have any compile time error, because Groovy will let you define, for example, the behavior of an object if it doesn't have a method. So if you call a method that doesn't exist, you can still do something, which is very useful for some cases. We can talk about that later if you want. And that was a problem. So for some people, at least, some are very familiar. For the Ruby guys, it's really something that they're familiar with. But for Java developers, it's really surprising behavior. So we added a fully static mode to Groovy that mimics basically what Java does, with even more type inference than what Java is capable of doing. And in that case, you have really the same behavior between Groovy and Java, with strongly typed features. And I would say that it's even more pleasant to use Groovy in that case because of the advanced type inference that Groovy provides.
So this type inference and this extra succinct or very clean syntax that you're describing, does that mean that Groovy lends itself to sort of scripting as well?
Yes, so there are multiple use cases for Groovy. So historically, the first use cases were really scripting, because one of the key points of Groovy is that you have Groovy scripts. And a Groovy script is basically what you would write in a Java class in the main method of a main class. And when I talked about boilerplate code, it's really that, in Java, if you want to write something and just test a few lines of code, you have to create a class and a main method, and inside you have to write that code. In Groovy, you don't have to do that. You just write the main body and it's executable as a script. So it was one of the main use cases of Groovy. And you were saying that I work for Gradle. So Gradle is a build system that uses Groovy internally, and you have build scripts, and those build scripts are written in Groovy. And the difference between those build scripts, and the Groovy script in general is that actually the build scripts of Gradle are what we call a DSL. So it's a domain-specific language built to create builds. So in the case of Gradle, of course, but Groovy is really good at designing what we call DSLs. So for those of you who are not familiar with the notion of DSL, it's really simple. If you take SQL, for example, SQL is a DSL. So it's a language that you design for one thing, which is querying a database. And in the case of Gradle, we have a DSL which is aimed at writing build scripts. And Groovy is really good at writing DSLs, designing DSLs. And historically, I started Groovy, using Groovy myself in the case of a DSL that was designed for linguists. And at that time, so when I started working with Groovy, what was really interesting is that I could design a language, so a domain-specific language, for those people, those linguists, and they didn't know anything about programming. And what they had in front of them, the file, the contents of the file was something that they could read. They didn't have any class inside, they didn't have any method call or something that looked like a method call in the eyes of a programmer, and still they were using a programming language without knowing. And I really appreciated that because Groovy makes it easy, and in the end, what you have, that DSL is compiled into something which is JVM bytecode, so you can still have the performance of JVM bytecode. And that's really something that really Groovy is very good at.
Interesting. So does this mean that you can is there a way to evaluate Groovy code live interactively?
Yes. So we have multiple tools for that. So one use case would be we really talk about DevOps those days, and for system administrators or whatever, it's often very practical to have some scripts that you can execute. And sometimes just to design the script, it's really useful to have some kind of REPL. So it's a read evaluation loop. And you just write code and it executes as you write it. It's really, really useful to design. So Groovy offers that. So you have a REPL, but that is the interactive mode of generating code. So basically when you do that, you have the code which is compiled and executed as you write it. This is one case. And the other one, which is interesting and I would say much more used in the reality by people who use Groovy, is that you can create and instantiate scripts at runtime. So during the application lifecycle, after it has been compiled, you can still compile scripts and execute them at runtime. So you really have the option to compile code at runtime. So the two aspects of the dynamic code execution.
I see. So can you take these scripts and then run them directly? And if so, do they get compiled? Is there a way to trigger the compilation directly, or upfront?
Yes. So you have the two options. So one is to just stay with scripts everywhere. That means that when you execute the scripts, it is parsed, it is compiled, and it generates JVM bytecode. So I think it's important to understand that when you have a script, a Groovy script, it's really not interpreted. It is compiled. So you have all the phases that you have in almost all compiled languages, which is you parse everything, you generate an abstract syntax tree, and then the abstract syntax tree is compiled down to bytecode and then executed by the virtual machine or the runtime, the language runtime, whatever it is. And Groovy has that. So if you have Groovy scripts, you can execute, for example, Groovy myscript.groovy, and it will do all that. Compile the script, execute it. But it is really one aspect of the language. And the other one is that you can write full applications in Groovy. And in that case, you don't want to recompile everything every time you run the application. Usually what you want to do is do what you have with Java code, with C++ code, etc. So with compiled languages, which is you compile the code, generates the classes, and in the end, what you deliver is a binary file, and you execute the application. And Groovy allows you to mix both aspects. You can have those compiled classes, pre-compiled classes, and you can have those script form classes.
Is that pre-compiled? Is there like a Groovy C or something like this?
Yes, so you have a Groovy C compiler, which is integrated with the most build tools that we have today in the JVM world. So you have the Groovy C command line tool, you have an AND plugin, you have a Maven plugin, and of course we have a Gradle plugin. So it's really natural to integrate Groovy into your Java projects. And I would even say that on the JVM, there's probably not any other language that makes it so easy to mix Groovy and Groovy or whatever language it is with the Java code. So you can use Java classes in Groovy code, but you can also use Groovy classes in Java code, and you can really mix. You can write one class in Java, one class in Groovy, and one call the other, and it's not a problem at all. For Groovy, you have what we call a joint compiler that will do the job of mixing the code. It's really interesting for that, because it means that you can start writing an application either in Java or Groovy and mix the languages. And it's really in the today we talk about polyglot applications, and it's really that spirit. You can have an application written in many languages, and Groovy makes it very easy to integrate with Java, actually.
You mentioned earlier that the language provides all the usual phases as a compiled language like Java. Because of the sort of plastic nature of the language, are there other ways to act on the code in other phases? Can I do things, for example, with the AST tree, like I could with a Lisp, for example?
Yes. So Groovy provides the two aspects. So we have metaprogramming in general, and we have the two aspects of metaprogramming. One is the runtime metaprogramming, and the other one, which is something I really like, is the compile time metaprogramming. So runtime metaprogramming is basically you can at runtime decide to add methods at runtime. So you have an object and you will decorate it with new methods, or you can change the behavior of calling some method at runtime. So that's one aspect. But since it's a compiled language and that we have access to that abstract syntax tree, actually we can also do some compile time metaprogramming, which is the methods, instead of being added, for example, at runtime, you can add them at compile time. And it is very important in case you want to have that interaction with Java classes, for example. Because say that you want to create a class that generates new methods. If you do it at runtime, the Java object will not see those methods, because Java is a statically compiled language. So if a method is not defined at compile time, it will not let you call it, of course, because it has to know ahead of time. So Groovy will let you do some compile time metaprogramming. So we call that in Groovy, we call that AST transforms, or AST transformations. So it's abstract syntax tree transformations. So it means that we have parsed that script, we have an internal representation of the program, which is the abstract syntax tree, and we can manipulate that tree to add some methods, to create new classes, to do whatever you want. And this is very powerful, because everything that you have is generated into bytecode, which makes visible to other languages. So be it Java, Scala, whatever you want. So you can call all those methods, all those classes generated at runtime. So for those of you who are familiar with Java, a good example of an AST transformation that we often use is the toString or equals and hash code. So those in Groovy are AST transforms. So that's basically an annotation that you put on your class. And once you've done that, the toString method is generated for you. The equals and hashcode methods are generated for you. So when we say that Groovy reduces the boilerplate, it also reduces all the common code that you have to write, but you feel that it is wrong to write that code because really the compiler could do it for you. You know, generating toString is really often just for debugging. It should be only used for debugging. It's not always the case, but anyway. And that code, you don't care to write it. You know, it's just you have to. So an annotation can generate it for you. So Groovy provides an annotation to do it. Yeah, it's the same for equals and hashcode. And probably another example in the case of design patterns would be the delegate design pattern that we often find in Java, which is you have a class and you delegate to another class to call. And actually in Groovy, it's super easy to do because you just annotate a member of your class with the @delegate annotation, and then it will generate all the delegation methods for you, which is also interesting because if you change the delegate type and you add a new method, you don't have to change the class which uses the delegate annotation. The compiler will do it for you. So it's really, really interesting.
Powerful.
And of course, all those methods will be visible from the Java side.
Wow.
Yep.
Do these AST transforms play into the DSLs that you've described, the capabilities that enable DSLs, and where are they used? What kind of DSLs besides Gradle, for example?
Yeah, so Gradle is one for the build system. So you have a very nice declarative syntax to declare what a build is, what the dependencies are. If you compare, for example, a Groovy Gradle script actually with a Maven XML file, you will see that it's much more human readable, just because you have that hierarchy and of scoped descriptive means of describing the build. But that's really one example. But in case of AST transformations, I think the best example that you can find of something that does very, I would say, crazy transformations on Groovy code is probably Spock. So Spock is a test framework, so for Groovy, but also for Java code. So you can use Spock even if you want to test Java classes.
So that's sort of like what you were mentioning earlier, the polyglot programming.
Yes. So we have a testing framework which is called Spark. So you write your classes, your test classes in Groovy, but you can test what is under test is actually Java code or Groovy code or Scala code. You don't care really what you want to test. It's really the syntax of Spark, which is pretty crazy. And you can have method names, for example, that have spaces inside. So you can have something like def, and you open the double quotes and say def should create a new database connection. And that's the name of your method. And inside, you will have some labels saying given something, when a connection is created, then you expect something. So it's some kind of behavior-driven development tool. And that makes everything incredibly readable. And for those of you who use JUnit or TestNG, moving back to that once you've tasted Spark is really awful, because Spark really makes it so easy to read the tests, and the syntax is very nice for that. And it's totally based on AST transformations of Groovy code, because if you take a Spark, it's called a specification. The test in Spark is really a specification.
Is that the same as sort of a behavior-driven development sort of spec?
but you can use it for both unit testing and more integration tests, whatever. It's a bit larger than just behavior-driven development. And if you take just the specification of the code and that you try to compile it just as Groovy code without Spark, it will fail compilation, and at runtime it would just fail. And the reason is that Spark internally uses AST transformation to transform the code of the method bodies to something which is actually doing the tests. So it's crazy, really crazy what it is capable of doing, and makes it very, very pleasant to test code in the JVM ecosystem.
Sounds very powerful.
It is.
Do these AST transforms and this metaprogramming and generally all these capabilities that you described that sound like they let you add new syntax or radically change existing syntax, do those features, are they well supported in IDEs?
So it depends. I would say that if you rely on runtime metaprogramming, basically, unless you explain to the IDE what your DSL is supposed to do, it will not know, because the behavior of the code it's a runtime thing. So the IDE will not know. So in Eclipse or IntelliJ, you have some DSL descriptors that you can write. And what is funny is that those descriptors are also written in Groovy. So it's a DSL in Groovy to describe the DSLs. So some kind of meta DSLs. And once you've written that, you can have IDE support. So you can describe to the IDE what your DSL is supposed to do. So that is if you use runtime metaprogramming. And one interesting feature of the language is itself, if you use the static mode of the language, which again is really something optional. You don't have to. It's by default, it's not statically compiled. It's not the static mode of Groovy which is enabled. But if you do, you can enable some very powerful features. And one of them is the type checking extensions. And may sound scary, but it's really not. The static type checking extensions in Groovy will let you plug into the type checking of Groovy, and you will be able to explain to the compiler what you are doing. And that makes it very powerful because, you were talking about the templating engine that Groovy introduced recently, and it uses that feature of type checking extensions. And basically what you have is a syntax, which is builder-like syntax. So you have HTML, then opening brackets, and inside you have body, opening brackets, etc. So it's code which looks like regular Groovy code, builder-like, but it is compiled statically. And it's template. And actually, the compiler doesn't know anything about a method called HTML, and it doesn't know about a method called P for paragraph or A for links. But you can explain to the compiler, okay, if there is a method that you don't know about, okay, I, as the designer of the DSL, I know what it does. And actually, it will call a method, which is, for example, create HTML node, which is the name HTML. And you can describe what the method is going to be called, what method is going to be called, and what is the type of the return type of that method call. So you can really describe and plug into the type checking system of the Groovy language just to enhance what it is capable of doing at compile time. So you have
like method missing, but even more powerful, because now you can say type missing.
Yes. Yeah. So you have, I'm not saying that it is easy to do, but it is possible to do it. And once you've done that, you can really have very compact and very performant DSL implementation, because you do not rely on runtime anymore. You can do everything statically, and you can really switch from a mode where methods are decided at runtime from something which is decided at compile time. So everything is known before you execute the code. So it's really, really interesting. And you can have some IDE supports for the generated methods for that. So
wow,
it's pretty cool. Yeah.
So far we've talked about how dynamic this language is in terms of the syntax that it can support, the ways that you can express concepts. It sounds like if you're a Java developer used to basic Java syntax, then Groovy will be just as welcoming as if you are an advanced developer who wants to really, really use the metaprogramming capabilities to their fullest.
Yeah.
Is there, I guess Spock is one use case, Gradle certainly is another. Are there other?
Yeah. So one of the biggest use cases of Groovy today is Grails. So Grails is a web framework that was originally inspired by Rails, and it's some kind of a problem today because people tend to think that Grails is just Ruby on Rails, but for the Java ecosystem. But Grails is really much more than that. Grails is a web framework, a full stack web framework, but it also provides some microservices capabilities. So you can design either a microservice or a full stack application. You can design web services with, if you want HTML backends, but you can also design REST APIs, whatever. And Grails is all about the plugin system. So it is powerful just because of the plugin system. And you can really make it very pleasant to design web applications on the Java ecosystem just using Grails. It's just because it will rely on the metaprogramming features of Groovy to remove all the boilerplate that you have to write. So just an example, if you want to have a controller, you would either annotate it with @controller or implement some interface, and it will automatically generate all the backend method for that. So if you have a REST endpoint, it will generate a REST endpoint, etc., etc. And it's really, really easy. It's just a few lines of code to create something.
So when you're using it like that, does it feel like a very clean and sort of light Java, or does it feel like a completely different DSL?
So the classes look very much like Java, but without all the boilerplate code again. So you have all those classes. So it's really readable for those of you who are familiar with Java, but you really focus on what you want to focus. You don't have to worry about creating all those all those wiring that you have to create for a typical web application in Java, especially if you think of GEE, So everything is wired automatically. You don't have to annotate anything. It's really by convention. If it finds something in one place, it will generate the code for you. So if you have a class which is in the control source repository, it will know that it is a controller without having to do anything. So it's really leveraging the conventions to make it much more concise.
So it looks and feels very similar, again, as you say, to a Java without all the boilerplate. It doesn't look like a different language altogether.
No.
It's not too far. You could easily come into it from there.
Yeah.
As you become more advanced, maybe you do Gradle and Spock.
Exactly. And I would say that often people, at least coming from Java, start writing Groovy as they write Java code. So it's really easy to find. If you look at Groovy code and you find a class which is written like Java, it's a beginner who wrote that, because you will find all the public modifiers, you will find semicolons everywhere, you will have all the parentheses, because in Groovy some of the parentheses are optional. You don't have to put them. So you see that, and eventually, as you gain expertise in the language, you start removing all which is not necessary. and you end up with something which is very clear to read. And
I see.
that is really one of the key selling points of Groovy, is that you can take that Java code and migrate slowly to something which is more Groovy-idiomatic.
I see. You've described several different modes of use, as a script, as a REPL, as a precompiled class. You've described that the language itself can be very lax with the sort of decisions about which types are in place, or they can be very strict because you have this static mode. How does the language? What are the language characteristics with regard to performance? I mean, is it comparable to Java, or is it more comparable to like a Ruby or a Python, or maybe faster than Java? Are there ways to optimize?
So yeah, there are multiple aspects of performance. So in general, what I say to people is that you don't care about the performance of the language until you have a problem. So because often people tend to say, okay, Groovy is slow, so I will not use it, and it's an error because often what is slow is really the database access or I/O, whatever. That's one aspect. But technically, you have several options in Groovy. So we have multiple runtimes. So you have the runtime, which is the dynamic runtime, fully dynamic runtime, and we have static compilation. So in case you use static compilation, basically the performance is the same as Java code. So it's more or less the same. It can be sometimes a bit faster, sometimes a bit slower, but same performance. It's very different if you use the runtime metaprogramming features in the dynamic runtime. So in that case, we have two runtimes actually for Groovy, because Groovy was created in 2003, and at that time there wasn't any support in the JVM for dynamic runtimes. So Groovy does a lot of magic into bytecode to be able to perform dynamic calls. So it uses reflection internally, but not only reflection, it uses also dynamic generation of code. So you have classes generated at runtime just to make it faster to execute code, etc.
Does that use something like cglib?
It doesn't use cglib, it uses ASM, which is the library that we use to generate bytecode, but it's very similar in concept to what cglib does. It's just that cglib is more suitable for proxies, basically. You can create, but we have some more general use cases for that. So we directly generate bytecode using the ASM library. So we do that in the traditional runtime, the legacy runtime. And since actually the release of Java 7, Java 7 introduced a new bytecode instruction in the Java ecosystem, which is called invoke dynamic. And that is really a revolution for dynamic languages like us. And it is also a revolution for Java itself, because if you know the lambdas in Java 8, actually lambdas use invoke dynamic internally. So the JVM itself uses dynamic invocation internally without you, the developer, knowing that. And that new instruction led us to develop an alternative runtime for Groovy, which is based on invoke dynamic. So depending on the target JVM that you have, you can either use the legacy runtime, which is still enabled by default today, or the invoke dynamic runtime if you use Java 7 or more. And the performance of the invoke dynamic runtime should be better. It's not always the case, just because when Java 7 was out, it was very buggy and not optimized, and it's much better now with Java 8, because since they use it internally for lambdas, they had to improve the performance of invoke dynamic. So if you use the invoke dynamic runtime of Groovy under Java 8, you will probably see a really good performance boost in Groovy performance for the dynamic runtime.
I see.
But in any case, to give you an idea, even if you take the legacy runtime or the invoke dynamic runtime, it's still much faster than what you can have with Ruby, for example. Even if you use, even if you use the dynamic runtime.
I see. So that's interesting. The invoke dynamic thing is something that came from the Java ecosystem and influenced some of the design in newer versions of Groovy. Have we seen other features that have influenced or changed the way Groovy works? And perhaps more interestingly, are there features from Groovy that have influenced Java?
Yeah, so it's really for invoke dynamic. It's really languages like Groovy or JRuby which influenced Java actually, because there were dynamic languages on the JVM like JRuby or Groovy that the designers of those languages asked the JVM guys to create something to make it easier to create dynamic runtimes, and it made it very, very easy to design something on top of that. And the JVM designers took all the needs that we had to create a dynamic runtime for Groovy, and they extended that to something which is more usable to more contexts. In this case, the lambdas, but it's really something that you can have, that you can see as an end user without knowing. And I would say that for Java 8, when you take a look at the lambda syntax, it's really actually close to what you have in Groovy. It uses a different syntax, but the concept of lambdas is very similar to the concept of closures that we had. So it would be probably difficult to say that Groovy influenced Java in that situation, but it's really something which is influencing in some way.
I see. Do you think there are other languages that have been influenced or been guided by something like Groovy?
Yeah, so recently, if you know the Swift programming language for iOS and even desktop applications on the Mac ecosystem, Apple ecosystem. So Swift is really language that took from modern languages like Groovy, Scala, and it has some features which are directly inspired from Groovy. So for example, the delegation, we have the concept of delegate on closures. And this is something that you can find in Swift. You can find it in Kotlin also.
Oh, interesting.
Yes, and Kotlin is another language on the JVM.
Is this the same delegation that you were referring to when you said you could do method delegation or to another method?
In that case, it's a delegation in a closure. So a closure, it's an anonymous block of code. So it's some kind of for JavaScript developers know that, because you have those anonymous function, and then you have a body. A closure is the same without having to declare all that function stuff. You just have the body, and that's all. And inside that body, you can have method calls. And the delegation strategy will say to which object actually those method calls refer to. So it's not something that you will find in Swift in particular, but Swift has some concept of delegation. Kotlin has some concept of delegation, but the Groovy concept of delegation is much larger actually than those languages. So you can really have some nice DSLs just because of that delegation system. And just to take another example of features that were borrowed from Groovy in Swift, you have that null safe operation. Yeah, it's called the Elvis operator in Groovy just because of the quote in the what's the name? I'm sorry, I'm French, so sometimes it's
Elvis Presley.
Yeah. In Java, it's often a nightmare to deal with those null pointer exceptions, just because you have to write if it is different from null, then call a method. And Groovy can simplify that, and you say foo quotation, not the quotation, and the interrogation mark. So foo interrogation mark dot some method, and then it will do the null check.
I see.
For you. And this is incredibly simple way of dealing with objects that could potentially be null.
So it removes the code path where you have to do an if else.
Yes. So this is something that a lot of people are asking for in Java, especially because in Java 8 you have that optional
Java util optional.
That optional wrapper or monad, whatever you want to call it. But it's not the same. It's really not the same. And especially optional involves a lot in terms of performance and what the VM is able to do. And in case of this operator, we don't do that yet, but potentially we can do some null type inference and totally remove the null checks in case we know that an object is not null. It's not possible with something like optional. So you have some performance implication in using optional types that you don't have if you use the explicit null checks.
So in this case, in a sense, Groovy written as idiomatic Groovy can be faster than idiomatic Java for the same sort of check.
In theory it could, but in practice it's not the case. It's often not the case, just because in the end we compile to bytecode, and the Java ecosystem has at least the most widely used JVM, which is the one provided by Oracle or the OpenJDK project. So the JVM has something which is called the JIT, it's a just-in-time compiler, and this compiler is able to transform bytecode, JVM bytecode, into native bytecode at runtime. So it optimizes everything at runtime.
Including optional checks?
No, it's not capable of doing that for the reason I explained. So it's not capable of unfolding optional type. But basically what it will recognize is patterns of bytecode which are generated by the Java compiler. So if we generate bytecode which is different from what JIT is able to recognize, it will not be optimized. So this is really some interesting parts of designing a JVM language, which is sometimes you find some patterns of bytecode which are faster than what Java is able to produce, but in practice it's often the opposite. It's something that you have to do, but since the Java language doesn't let you generate that kind of code, you don't have optimizations available. So you were talking about future improvements of the Java ecosystem, and actually there is a Java enhancement proposal, which is help the JIT. So basically it would let us designers of JVM languages to explain to the JIT what kind of patterns we generate so that it can optimize them too.
Interesting.
Yeah.
This is a JSR? Java specification request?
I don't remember exactly, but I think it's not the JSR, but the GEP, so the Java Enhancement Proposal. But maybe I'm wrong. Maybe it's JSR already. I'm not sure.
No, okay. I'll try and link to that in the show notes.
Yep.
Related, there was a now dormant JSR 241 from 2004, which tried to standardize Groovy.
Yeah.
Will that ever come back, or will there ever be an attempt to make that happen again?
So it's very unlikely that it will come back. It's a very huge work to write a specification of a language, especially after the fact. And so we had two options. Either we concentrated on improving the language, bug fixing, or designing and writing the specifications. And we decided to go halfway. We have significantly improved the documentation of the Groovy language, which was a major pain point for a lot of people recently. But we have now a new Groovy documentation, which kind of looks like a specification. And when we say that, it's actually that if you go to the Groovy Lang website and that you read some documentation and that documentation contains a snippet of code, you can make sure that actually it's tested. So when we compile actually Groovy, we compile all the snippets of code that belong to the documentation. So we document the language and the behavior of the language, so specify the language after the fact by describing exactly how it behaves. And since we have all those documentation snippets of code included in the build, actually, if we ever break something, the documentation is broken. So we can make sure that we don't break the existing behavior of the Groovy language.
A strong regression suite.
Yeah, so it's more than just documentation. It's really expliciting everything we do, and it's not as technical and as detailed as a pure specification as you can find in Java specification.
I see.
Itself.
Has this impacted the community size? How big is the Groovy community? Do we know? Is there a way to measure?
So we don't have a clear figure of how big it is, but we have some download figures. And I think last year Groovy was downloaded almost 5 million times.
Wow.
So that's really, there are a lot of people using Groovy, and I would tend to say that a lot of people use Groovy without knowing it. So if, for example, if you do some Android programming and that you use the new build system, actually you use Gradle, so you use Groovy without knowing you use Groovy.
Huh.
If you use Jenkins for continuous integration, Jenkins is deeply integrated with Groovy. You have that new workflow system, for example, which is written in Groovy. It's a Groovy DSL. So you have Groovy everywhere. And it's used in a lot of applications and really in big systems, scalable systems. So you have some people saying that Groovy doesn't scale. It's really, really not true. I mean, we have the proof that it's the opposite, actually. So, yeah.
I know that large companies like very large web companies like Netflix use it quite heavily.
Yeah, that is interesting. For example, every time you click on Netflix to watch some episode, it goes through delegation system which is written in Groovy. So yeah.
How many committers are there working on the language? I mean, how does it get maintained now that you're part of the ASF?
So we are currently we're migrating to the Apache Foundation, which has a concept of what is a committer, and I would say the active committers, people that write code often, commit often on the code base, it's about 6 people, but the community of people contributing to the language is much larger than that, and we have more than 100 people contributing to Groovy, and it comes from just contributing some, I would say, just fixes in the documentation. Without having to know the Groovy code base itself, you can just fix the documentation. There are also people contributing some small bug fixes, and it can come as far as complete new features. So, for example, we have some new features around compile time make-type programming coming. These are big features that involve a lot of code, and those are user contributed. So it's a very, very wide community and active community. And
I see. And you mentioned Android earlier. One amazing thing you can do with Groovy these days is actually run it on Android. Can you speak about that?
Yeah, sure. So I would say that for people who are used to develop applications in Java on Android, it's probably a nightmare if you know about Java 7 or Java 8, just because the code is very Java 5 stylish. I often say it's the anonymous in the class paradise. You have anonymous classes everywhere, boilerplate everywhere. You have all those views that you have to bind. You have to find the view by ID, etc., etc., etc. And actually, what we wanted to do with Groovy on Android is what we had done for Groovy on the desktop, on the server. So it's really remove all that boilerplate code that you have to write to create an Android application. And I think we somehow managed to do that because we have some people who started using Groovy for Android before it was actually official, just because it removed so much boilerplate code that it was a pleasure, again, to develop applications on Android. So the best example for that is the New York Times application on the Google Play Store. So that the new application is fully written in Groovy.
Wow, that's amazing. That has a lot of users.
And a lot of users, yeah. So it's really interesting to know that. And really, we have also an active community around that Android sub-project. So Groovy itself is a language that can compile to Java and bytecode, so we support Android now. But in Groovy, since it's a language, you have all those micro communities. So we have the Grace community, we have the Griffin community for the desktop, and we have now that Android community. And those people are writing new libraries that are designed to take advantage of the Groovy language to make it very easy to write Android applications. So, for example, leveraging those annotations, those AST transformations to reduce the boilerplate code and not having to inject those views, for example. It's just really a simple example, but you don't have to generate that code anymore.
So perhaps the number of downloads will be even bigger next year now that we've got these new communities springing up.
We hope that, but unfortunately, now that we have moved to the Apache Foundation, the download figures are going to be more difficult to get because of the mirrors. You know, in Apache, all the downloads are, it's all on the mirrors, so you don't have download statistics.
Now that Groovy is part of the Apache Software Foundation, what do you see as once you're past incubation and the language is on track again? What do you think the next big features will be? What's the next version of Groovy look like?
Yeah, so the next version of Groovy, the next major version of Groovy, so Groovy 3, is probably going to abandon support for all the JDKs. So that's because we want to leverage the full power of Invoke Dynamic. So today we have that Invoke Dynamic runtime, but because of the history of the language and how it was designed, how the meta object protocol was designed, we cannot take advantage of the full power of Invoke Dynamic, and especially in terms of performance. So we would like to redesign the meta object protocol for it to be cleaner, faster, and leverage Invoke Dynamic fully. And that requires us to abandon support for Java 7, Java 6, and Java 5.
Would that mean that the Android port would no longer work?
Yeah, today if you take a Groovy code and that you compile it, you can execute it in Java 6 and Java 7. And that is really interesting for people that cannot use, for example, Java 8 and the Lambda syntax. You have the same Groovy basically with the closures, but you can have it on all the platforms on Java 6, I would say, on Java 7. And for Groovy 3, probably abandon that, just because we need to be able to move forwards in terms of performance. And to do that, we cannot rely on the old protocol. So it's going to be a big change. And that's the long-term development that we want to have for Groovy, but we have more features to come for dot releases, I would say. So 2 dot something. And one of them is the 2.5 release, which is probably going to bring in the new macro stuff. And that macro stuff is AST transformation simplified, basically. Because doing runtime programming in Groovy is really easy, doing compile time metaprogramming and especially AST transformations is much harder because you have to know more about the compiler itself and how it works. And what we want to do in Groovy 2.5 is simplify that using some kind of macros, and you could write AST transformation much more easier in that case.
Okay. Well, Cédric, do you have anything you want to tell the listener? Anything you want to encourage them to check out? Where can they go to learn more about the Groovy language, for example?
Yes, so the first thing obviously is to try the language. So it's really easy to do. So if you're under Linux, you can use the JVM tool, so it's GVM, and it makes it very easy to install Groovy and test it. But obviously go check out the new website of Groovy, so it's groovy-lang.org. And we have that new documentation, which is really, I think, much better than what it was before. But we also need your help. I mean, if you want to invest some time in a cool open source project, just help us. Especially now that we're under the hood of we're in the Apache Software Foundation, we can have now a much more broader development and open source development process. So you can still contribute directly on GitHub. We have some mirrors on GitHub if you want to, but you can contribute some fixes or just help us reporting bugs. Just reporting bugs is very important. So yeah, helping can be just as easy as that, submit a pull request or submit bug report, yeah.
And what about you? If they want to find out more about you, are you on Twitter? Do you have a website?
So I am on Twitter, so it's Cédric Champeau, and I'm also on GitHub for hosting my blog post. So the blogs posts I write are also on GitHub, so it's all open source. I am a big fan of open source. You can find all my blog on GitHub. And it's probably going to paste the link to that on the show notes. But if you want to have something which is written in Groovy and generates a blog, you can check out my own blog, and you would have something which is really cool.
Very cool. Okay, we'll have links to that in the show notes. Thank you very much, Cédric, for joining us today. I hope it was worth your time.
And thank you for the invite. It was a very pleasant time.
Good to talk to you. Dear listener, we want to hear from you as always. There are many different ways that you can reach us. Please feel free to comment on the show on our website, se-radio.net. You may email us at team@se-radio.net or send us tweets on the Twitters at SERadio. We're also on LinkedIn, on Google+, and we have a software engineering group where you can find us there, and we're always, as usual, happy to hear from you. With that, I am Josh Long. Thanks everyone for joining me and joining Cédric. Goodbye, Cédric. Have a good day.
Goodbye, and thank you.
Cheers.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.